Hi, this is Dr. Yusuf Mulge, professor in CSM department. Today I am going to explain about the searching strategies, searching algorithms. Now, in case of the searching algorithms, so any problem has maybe having a solution. Every problem may be having a solution. So then with that solution we need to search. Okay. Now, the best solution may be search based upon the technique that we are using for searching techniques. So, therefore, the searching algorithms will provide the finally whatever is the solution, whatever is the goal of a problem. Now, there are different types of searching strategies. Okay, one may be the DFS, another BFS, and then the many types of searching technologies, searching strategies, searching algorithms are present. Now, so different terminologies that are being used in searching strategies are completeness. Now, completeness is the one when we say whether the goal is reached or not, the solution is found or not. So, based upon that, so if the goal is found, if the solution of the problem is found, then it is said to be a complete searching algorithm. Then optimality. Now, with what effort the solution is found, okay, that is called as the optimality. That is how many steps we have moved, how much time it took, how much space it took. So, based upon that condition, if it can be achieved, if the solution can be achieved with the minimal number of steps, with the minimum memory it is used, which minimum time it is used, okay, that is called as the optimality. Okay, then time complexity, how much time is required, how much time it consumed to find the solution, that is called as the time complexity. Then space complexity. Now, most of the searching algorithms, they will store the previous move, okay, so that it can use that previous move to move to the next stage. Okay, so for that purpose, how much memory it has used, so that is called as the space complexity. Therefore, here the terminologies that are being used in case of the search strategies are completeness, optimality, time complexity, and space complexity. Now, there are types of searching algorithms. First category is the uninformed search. Second category is the informed search. In case of the uninformed search, the domain knowledge of the searching space, the domain knowledge of the search space is not available. Therefore, it is called as the uninformed search strategy. The second type of searching strategy, informed search strategy, where the complete knowledge of the domain is available. Okay, so like that here, two types of search strategies, two categories of the search strategies are there. In case of the uninformed search strategy, first is the breadth first search, second uniform cost search, third depth first search, fourth depth limited search, fifth iterative deepening depth first search, sixth bidirectional search. So these are six types of search strategy in case of the uninformed search algorithms. Okay. In the case of the second category, informed searching techniques. So one is the best first search, second is the A star search. These are the two search algorithms used in informed search algorithms. Now, starting with the uninformed search, the breadth first search is the most common search strategy used. Okay, as the name itself implied, okay, breadth wise the solution is found here. That is the searching strategy, searching algorithm will try to search the solution breadth wise in a tree. Okay, that means here before going to the next level for first one level is completed for searching the solution, then it will go to the next level, that is next level, and then we'll try to search the solution. So like that here, level by level, the algorithm will search for the solution. Okay, now that is the most common used. Now here the breadth first search, BFS, is it starts from the root node and will expands all the successor nodes into the level wise. Okay, breadth first search is implemented using FIFO. Okay, first in first out algorithm. Now the advantages of the BFS algorithm are that BFS will provide a solution if at all the solution exists. Okay, if there are more than one solution for a given problem, then BFS will provide the minimal solution, that is the solution which can be found by moving minimum number of steps. Okay, by providing the less time or less space, it will try to find out the solution if multiple solution exist. Disadvantage of the BFS is that here the BFS requires lot of memory to store the space, to store the solution path, because first after completing one level, then it has to move to the next level. So it will store the complete information of the previous level so that it can move to the next level. Okay, so for that purpose it requires memory. So a lot of memory is required for BFS. Okay, BFS needs lot of time to find the solution if the solution is far away from the root node. If the solution is very close to the root, then it will find out the solution very fast, and even it requires very less memory also if the solution lies very close to the root node. Whereas contrary, if the solution lies far away from the root node, it requires more memory, it requires more time. So this is the disadvantage of the breadth first search, BFS. Now if we consider a tree, then for example at the root it has a node called as S, that is the level 0. Then then S has the children A and B, so that is the next level, level 1. So like that, level by level it will try to find out the solution, and then if solution is available, it will return success, otherwise it will not return. The next type of the searching algorithm is the DFS, depth first search. So the depth first search is a recursive algorithm, okay, traversing in a tree or in a graph. So recursively it will try to find out the solution. Okay, so for that purpose it will move very deep into the tree, and then after that is, so it will not move breadth-wise, it will move depth-wise. It will move very deep into the tree and will try to find out the solution. Now it will follow each path in the first left tree it will consider, then after the left tree, once it goes up to the leaf node into the left tree, then it will go to the root again, and then it will select the next branch and it will go to very deep into that branch. So likewise, branch as branch, it will consider the solution, it will try to find out the solution. Now in this case, when the algorithm traverses very deep into the tree, then it may not come back, it may not retrace back. So this is one of the major disadvantage of the DFS algorithm. Now the DFS uses stack data structure, okay, for its implementation. Okay. The process of DFS algorithm is similar to BFS algorithm but moves depth into the tree. Advantages. Here DFS requires less memory because it does not have to store the previous information. Therefore, the memory is not at all required for depth first search algorithm. But the disadvantage is that it may stuck up very deep into the tree. Okay, now here the root node to the leaf node, the path from the root node to the leaf node is not required to be stored. Therefore, memory is not required here. It takes less time if the goal is very much close to the root node, because it will go deep and then it will find out the solution very fast. Disadvantage of the DFS algorithm is there is possibility of many states keep reoccurring. Many states may reoccur again and again. So repeating the same number of steps. So it can do. Therefore, it is the disadvantage of the depth first search algorithm. So now DFS algorithm goes far deep down into the tree. So where there down into the tree, it may stuck up into infinite loop. Okay, so from the infinite loop, it may not come back. So this is the disadvantage of the DFS. Now here that is, if you consider the figure, S is the root, then S to A to its child it will go, then A to B it will go, then B to D. So now the left branch of the left tree is completed once it reaches the D. Then after that it retraces back to the next branch C, and then it will follow the path E and then G. Okay, like that here. So left branch it will consider, left tree it will consider, and will try to find out the solution into the left tree. Then after that, to overcome the drawback of the DFS, okay, where it will go very deep into the tree and there it may enter into an infinite loop. So to overcome that drawback of the DFS, so one more algorithm has been proposed, that the algorithm is the depth limited search algorithm. Now, as the name itself implies, in case of the depth limited search algorithm, it is similar to the DFS, similar to depth first search, but only thing difference here is that the depth is fixed here. The depth may be fixed to a level of 2, level of 3, and so on. If the solution is not available even in level 3 also, then again the depth may be increased to level 4. Like that, iteratively, the depth will goes on increasing and it will find out the solution. Okay. Now it may not stack up into the very deep into the tree. Depth limited search can solve the drawback of the infinite path into the depth first search. In this algorithm, the node at the depth limit, okay, now the solution at the depth limit if is available, then it will find out the solution. That means completeness of the algorithm will be there. So if the solution is not found into the depth that is fixed, then failure occurs. Okay, that is the completeness will lose. So this is the major drawback of the depth limited search. Depth limited search terminates at two conditions. One is that one is that standard failure value. Okay, so it indicates that where if the solution is not available, then the standard failure occurs. Okay, this is the first condition where the depth limited search may fail. Okay, then second is the cutoff failure value. Okay, no solution is available. So if there is no solution available, then depth limited search will fail. Okay, under these two circumstances only the depth limited search will fail. Okay, advantage of the depth limited search is it is memory efficient, because here the previous state of the tree is not required to be stored. So therefore, it is memory efficient. Memory is not required. Disadvantages of the depth limited search is that so it may lead to the incompleteness of the algorithm. So if the solution does not lie into the depth limit that is fixed, then it fail and it is incompleteness of the algorithm. It may not be optimal because when there are more than one solution occurs, then it may not be optimal. So these are the two drawbacks of the depth limited search algorithm.